Hi everyone, my name is Madison Webb, and I'm going to present Chapter 10, Process Implementation with Executable Models from our textbook. This chapter focuses on turning a process diagram on paper into a system that a computer can actually execute. So here's a quick overview of what I'm going to cover. How to decide which parts of a process can be automated. How to deal with manual work that people still need to do. Why exceptions, those unexpected things, matter so much. How to make sure we include all the right data for tasks to run properly. How to break down tasks into just the right size. What technical details a system needs to actually run the process. And finally, how to choose the right system, called a BPMS, and to implement it. Let's start with the basics. What is a BPMS? BPMS stands for Business Process Management System. It's like the brain of a process automation project, making sure every step happens in the right order and at the right time. A BPMS helps us assign tasks to the right people so the right person handles the right step. Connect to other systems like an inventory or finance database to get information or complete tasks automatically. Keep track of where each step is in the process, kind of like a GPS for our workflows. This coordination is what allows a process model to go from a diagram on paper to something that a system can actually run. Let's ground this in the real world. Where do we actually see BPMS in use today? In healthcare, BPMS helps coordinate patient care, managing medical records, scheduling appointments, and even handling billing processes. In retail, companies use BPMS to streamline order fulfillment, checking stock, picking products, and shipping them. In banking, BPMS is used for things like loan processing, ensuring that applications get reviewed and approved efficiently while handling exceptions along the way. And in manufacturing, BPMS keeps production plans on track and ensures quality control by coordinating different departments and systems. These examples show how BPMS bridges the gap between people and technology in complex processes. Before we can automate anything, we need to figure out what can actually be automated. Imagine planning a new kitchen. Some steps can be done by machines, but some require human touch. In process modeling, we break tasks into automated tasks. These can be fully handled by the system, like checking stock levels. Manual tasks. These require a person, like physically packing an order. User tasks. A human does the work, but it is guided by the system, like reviewing and approving a document. In our example of an order-to-cash process, the system checks stock levels automatically. No human needed. But a warehouse worker still physically gets the product. That's manual. And an order clerk might review an order on a screen. That's a user task. Identifying these boundaries helps us see which parts of the BPMS can coordinate and which parts need human involvement. Now let's think about those manual tasks. Even though a BPMS can't physically pack a box, it still needs to know that the packing happened before moving on to the next step in the process. We have two main ways to handle that: turning the manual task into a user task or an automated task. The first one, user task. The worker logs into the BPMS and marks the task as complete. Think of it like checking off a to-do list. The second one, automated tasks via devices. Imagine a barcode scanner that tells the system the product is picked and packed. This way, even though the task is manual, the BPMS stays in the loop and can keep the process flowing. However, sometimes it's just not practical to hook everything up to the BPMS. So for example, a university admissions committee that meets to review applications. That's a group of people having a conversation. It's not really a structured task that a BPMS can follow. So what do? We let the BPMS automate the steps before and after the committee meeting, like collecting applications and sending letters. Then we just skip the meeting itself. After the meeting, the BPMS can pick up again by processing the results. We call this splitting the process, and it's a key part of balancing automation with human collaboration. Once we've identified what can be automated and handled manual tasks, we need to make sure our process model is actually complete so the system can run it. Two main ideas. First, exceptions are the rule. Real life is messy. Orders get canceled. Systems fail. We need to build exception handlers into our model so the system knows what to do when things go wrong. Second, no data means no decision. Every task needs to know what information it's using and what it's producing. For example, if we check stock levels, we need to know which product we're checking and where the result goes. Without these details, the system can't make decisions or hand tasks off to the next step. Now, let's take a closer look at exception handling and data mapping. First, think of exceptions as all the what-ifs in a process, like when a supplier runs out of stock or a customer cancels an order at the last minute. These situations can throw a wrench into our plan. To make sure the BPMS doesn't get stuck, we need to define what should happen when things go wrong, like returning a product or issuing a refund. This is where our exception handlers come in. They're like a safety net for our process. Second, let's talk about data mapping. Every task in our process needs to know exactly what information it's working with. Imagine a warehouse worker picking a product. They need the product code from the purchase order to find the right item. If the BPMS doesn't pass that info along, the process comes to a stop. Data mapping is like making sure the right ingredients go into the recipe at each step. In short, exception handling keeps things moving when the unexpected happens, and data mapping ensures that every task has the information it needs to get the job done. Now, let's talk about task granularity, making sure each task is at the right level of detail for the BPMS to handle it effectively. If a task is too big, like process payment and approve refund, it might need different people or systems. So we should split it into smaller, separate tasks. This ensures clear responsibility and helps the BPMS manage handoffs properly. This is also called decomposition. But if a task is too small, like entering a customer's name and phone number separately, it's better to just group them into one step or aggregate them, like enter customer information. This way, the BPMS isn't micromanaging every small action. So finding the right balance makes sure each task fits how people work and how the BPMS coordinates work between those tasks. Next, let's talk about ad hoc sub-processes. Those parts of a process where tasks don't happen in a strict order. Think of customer service, where checking an order, updating details, and canceling an order might happen in any sequence. BPMN, our usual process modeling language, prefers step-by-step flows and struggles with these flexible parts. In these cases, we can use something called CMMN, Case Management Model and Notation, which lets us define tasks that can happen in any order or even repeat. It gives us the flexibility to capture real-world work without forcing a rigid sequence. Using CMMN alongside BPMN allows us to handle both structured and unstructured work in our BPMS. Next, let's talk about making our process model executable by BPMS. Once we have the tasks, flows, and events defined, we need to specify key technical details so the BPMS can run each step properly. First, every data item, like a purchase order or a stock level, needs a precise definition so the system knows how to handle it. For tasks that interact with external systems like checking stock in an ERP, we have to define how the BPMS connects to them, what response it expects, and how to handle errors. User tasks also need details: who does them, how they're assigned, and how they appear in the system's interface. Lastly, for decision points, like deciding to ship a product or not, we need clear conditions. For complex rules, we use DMN tables to define them separately from the process flow. Specifying these details turns our model into an executable process that the BPMS can manage efficiently. Let's bring everything together with the order-to-cash example. In this process, the system automatically checks stock availability by calling the ERP system an example of an automated task. Then, a warehouse worker physically retrieves the product, a manual task that's either confirmed via a scanner or marked as complete in the BPMS. Finally, an order clerk confirms the order using the BPMS interface. This is a user task. This mix of automated, manual, and user tasks shows how a BPMS can coordinate a process that involves both people and systems, keeping everything moving smoothly from order to delivery. Finally, let's talk about choosing the right BPMS to automate your process. Some BPMSs are designed from the ground up to use BPMN, making them a great choice for strict BPMN compliance. These are called pure BPMNs. Others originally used a different approach, but now support BPMNs. They let you import and export BPMN diagrams while still using their own underlying engine. These are adapted. And some systems don't support BPMN at all, or non-BPMNs. They use their own language and rules. It's also important to remember that even BPMSs that support BPMN may not support every feature like compensation or certain events. So you'll need to pick a BPMS that aligns best with your process requirements and the features you need. Before we wrap up, let's quickly review the key takeaways from the presentation. Not all tasks can or should be automated. Some tasks need a human touch. BPMS acts like a conductor, coordinating different kinds of tasks, automated, manual, and user tasks, to keep everything flowing. Handling exceptions and managing data are essential. Real-world processes rarely go perfectly. Finally, choosing the right BPMS is key. Some are designed from the ground up for BPMN. Others have evolved from different tools, and a few use their own approach. These takeaways will help you understand how to go from a process diagram on paper to a working, automated process in a BPMS.
Alright, let's bring everything together in a quick summary. We started by learning that not every part of a business process can or should be automated. That's why the first step is to identify the automation boundaries, understanding which tasks can be handled by a system and which ones still need a human touch. Then we explored how manual tasks can be connected to the BPMS using user tasks or devices like barcode scanners. But sometimes it's just not practical to connect every manual task, so we need to know when to leave them out. We talked about making sure our process model is complete by adding exception handling and defining all the data each task needs to work properly. Without this, the process might fail or stall. Next, we discussed granularity, making sure our tasks aren't too big or too small. We want each task to make sense for both the people involved and the BPMS, coordinating everything. We also learned about ad hoc subprocesses, those parts of the process that don't have a strict order, and how to handle them using techniques like CMMN for flexibility. Then we covered specifying execution properties, which means defining all the technical details a BPMS needs actually to run the process. That includes data definitions, service connections, user task details, and decision rules. We also saw a real-world example, the order-to-cash process, and how automated, manual, and user tasks work together to complete the process. Finally, we looked at the different types of BPMS, peer, adapted, and non-BPMN systems. and why it's so important to choose the right one based on your process and technology needs. By pulling all these pieces together, we can take a process diagram that's just a picture on a paper and turn it into a fully functional system that runs smoothly, handles exceptions, and keeps everyone on the same page. Thank you so much for listening. I hope this presentation has made the chapter clearer and given you the tools you need to understand how to implement business processes with executable models.